Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about OEL 2, which is open-ended level lab 2. Okay. Firstly, my name is Muhammad Irfan. I will talk about the introduction. Basically, our OEL 2 is same as OEL 1, which is control fan system, but for OEL 2 which only add one part, which is timer. Okay. The condition or part we use for this OEL, which is LED, state LED, switch, PC lab, simulator, and timer. Okay. Next part, I will pass to Muhammad Nabil about the objective.
Assalamualaikum. My name is Muhammad Nabil bin AZLAN. Today, I will tell you about the objective. The goal is to create a microcontroller-based fan control system with timer functionality. The system will use a push button to switch between low and high fan speeds and an LED indicator to indicate the selected speed. The timer controls the LED's blinking effect. The system aims to improve comfort and energy efficiency by providing reliable and efficient fan control. It will use appropriate timing intervals for LED blinking based on the selected speed, ensuring optimal airflow and fan operation. The user-friendly interface allows easy operation and customization of fan speed. Users can easily switch between speeds by pressing the push button, and the LED indicator provides visual feedback on the selected speed. Testing and refinement of microcontroller-based fan control systems ensure functionality, reliability, and user-friendliness, enhancing comfort and energy efficiency. Thank you.
Here I will explain methodology. In here, we use two switch as input and LED as output. When switch 1 is pressed, it will show high-speed LED output with 0.5 second blinking. After 5 seconds, it will change the blinking into low speed, which is 1.5 second blinking. To change the speed, we use timer command, and the blinking we use delay command. And if we want to stop it, we use switch 2 as a button to deactivate the command. Here the result.
Hi, my name is SHAHRUL bin SAPRI, and I will be discussing the modification made to the LED control program, transforming it into a fan control application using the PIC 16F877A microcontroller with a focus on the role on the timer. The initial program focused on controlling an LED based on the state of push buttons. However, we have adapted the program to control a fan instead. Let's dive into the implication of this modification. The modified program allows users to control the operation of a fan using a push buttons. By pressing a push button switch 1, the fan turns on and it remains operational until switch 2 is pressed to turn it off. The significance of this modification lies in its practical applications. This type of fan control system can be applied in various scenarios, such as home automation, HVAC systems, or personal cooling devices. Adapting the program for a fan application involves changing in I/O or input-output pins and adjusting control logic. For instance, the fan is connected to a specific pin, let's say it's port B, port D, or port A on the microcontroller, and the trace register is configured accordingly. To provide more control, we can incorporate paths with modulation PWM signals to adjust the fan speed. This can be achieved by varying the duty cycle, which affects the average power delivered to the fan motor. The program's output reflects the behavior of the fan base on the push buttons itself. Pressing switch 1 turn on the fan and it continues. It continues to operate until switch 2 is pressed to turn it off. This provides a simple yet effective control mechanism for the fan. However, we can further enhance the fan control system by implementing safety features such as temperature monitoring enables automatic fan control based on temperature threshold, ensuring optimal cooling and energy efficiency. Additionally, incorporating adjustable speed settings or predefined fan speed profiles based on specific requirements can provide users with more control and customization options. Improving the user experience is another consideration. Visual feedback through LEDs or display modules can be indicate the current fan state and speed settings, and it will make it easier for user to interact with the system. Now, let's hear about the conclusion from the next speaker, which is AFIFAH. Thank you very much.
Assalamualaikum. My name is Nur Ali Afifah binti Abdul Razak. The conclusion is the microcontroller-based fan control system is using PIC 16F877A microcontroller, switch, LED and timer. Achieve its objective. Control fan speed with a push button and LED provide visual feedback. The system functionality and reliability have been verified through a testing and is a user-friendly and efficient. For the future work, there are several potential enhancements that have been considered. One possible improvement is to integrate a temperature sensor or humidity sensor into a system. They will allow the fan system to be automatic adjust based on the environment condition, provide optimal cooling or ventilation. In addition, implementing wireless connecting or integrating the system with a smart home technology could feature enhance conveyance and control. Thank you.